My colleague and friend all the way from Spain, Professor Guillermo Seville. He will join Professor Susan Barman to help us to judge here. Professor Susan Barman told me something interesting, which I'm sure she doesn't mind me telling you. She said that when she was a student, she used to sleep with her lecture notes. And of course, she was very young then. She believes that somehow by osmosis, the information could, perhaps it has worked. There you are. She's a co-author of a physiology book. So is that's evidence-based medicine. Anyway, give an example of effective osmotic pressure. Yeah. Yeah. You must ask her whether the notes have to be in handwritten or digital ink. Yeah. Handwritten, yeah, okay. So are we ready? Okay, yeah, okay. Your question is, what is the ratio of interstitial fluid volume to plasma volume? What is the ratio of the interstitial fluid volume to the plasma volume?
Three.
Okay, we'll let him answer because it's okay. Yeah.
Three.
Three what? Three.
The
ratio
is three.
Three. Three is the number, the ratio. What is three and what is? Yeah, it's a ratio.
Yeah.
You only given me one number. Three. Three is not a ratio. So it's the ratio of ISF to plasma. So what is the ratio? You say 3. What is 3? It's okay, yeah. 3 is not a complete answer. The ratio of ISF to plasma. When you say 3, what do you mean by 3? What do you mean by 3? Just tell us what you mean by 3. No, just explain why you say 3. What does a 3 means? Just tell us why you say 3.
It's the interstitial fluid is 4/3 of the volume, and the plasma volume is 1/4.
No. Just simplify. You gave me the answer as 3. So what does this 3 means? What is 3? Plasma is 3. Interstitial fluid is 3. Maybe it's a language problem. Yeah. Do you understand the word ratio? Yeah. What is the ratio? What is the ratio of interstitial fluid to plasma? Quick, give your answer.
75%.
Yeah, don't make your answer more complex. We just want to know what you mean by 3. Is the plasma volume bigger than the interstitial?
No.
Then which way? No, what does your 3 mean? Just explain why you say 3. That's all. There's no calculation involved. So just answer the question.
75% fluid.
No, we don't want percent. It's a ratio. Yes, sir. we're getting a bit complex. Okay, the interstitial fluid over plasma, is that kind of, yeah, something like that. So you say 3. So what does the 3 represent? 3 what? 3 times or 3, whatever? 3 times. What is 3 times? Which is bigger? Interstitial fluid is 3 times bigger than plasma. That's correct. We just want you to say 3 to 1. Yeah, because if you say 3 to 2, it's different. You have to say 3 to 1. Okay? Yeah. Wow, that was a long answer. Yeah. Yeah, 3 to 1. Okay? Yeah. Okay. Yes. Thank you. Yeah. Okay, let's move on. If the ovulation is on the 9th day, 9, okay, how long is the menstrual cycle? Explain your calculation. If the ovulation is on the 9th day, 9, how long is the menstrual cycle? Explain your calculation. One minute. He wants to answer. What? Let him answer. Okay, give a quick answer. Yeah, the number. We let him answer. Yeah. No, just answer. What is the? How long is the menstrual cycle? Give your answer first. Give your answer. What is the answer? Look. Hang on, wait. What is the answer? No, just answer. How? There's a number, right? Just give me the answer.
14 days before.
Is that your answer? Answer is wrong. Yes, correct.
23 days.
Explain your calculation.
The luteal phase remains constant for a 14 days per cycle.
That's correct, yeah. Okay, so we just want you to say 23 because 9 plus 14, that's all. Yeah, okay, yeah. Okay, your question is, in the glomerular filtrate, what is the pH and the concentration of hydrogen ions? In the glomerular filtrate, what is the pH and what is the hydrogen ion concentration?
The pH remains 7.4.
Concentration?
0.0004.
Answer is wrong. Yes?
I think pH remain normal and it is 7.4. So the hydrogen ion is 10 power 77.4.
10 what?
Power minus 7.4 of 10.
pH is 7.4, is it? Yeah, okay. The concentration in terms of moles. You're giving me the calculation, how to calculate it. Okay?
Calculate the hydrogen ion.
Yeah, you don't have to calculate, it's just a standard number. What is the concentration of hydrogen ion in moles in the glomerular filtrate? That's a normal value.
Yes, normal value.
Yeah, we want the value from you.
10 power
Yeah, you're telling us how to calculate it.
power minus 7.4.
What's the answer to that? No, you're telling me how to calculate, but we're asking you for the value. Like potassium is 4 millimolar, okay?
Yeah.
So what is potassium hydrogen ion concentration in the filtrate?
It's a 0.
Okay, I think it's probably not possible to calculate it there. Yeah. Okay, so we have to give you the answer, I think. It's 40 nanomoles. 40 nanomoles at pH 7.4.
Yes.
Yeah. So we cannot accept your answer. You didn't get the second part.
My value comes to the same. 0.0004 milliequivalents per liter. It's millimoles for hydrogen equivalent and moles are the same.
0.004.
0.00404.
But it's nanomoles. Yeah. No, it's not correct. Yeah. Okay, I think we cannot accept both answers. Yeah, it's 10 to the power minus 9 nanomoles. Okay. Yeah, because we heard it as millimoles, so it's not correct. Yeah. What unit did you say? Sorry.
Milliequivalent, which is equal to millimoles for hydrogen. It's the same. Yes.
Zeros. Okay. You heard it? So you gave it as 0.0004 millimole per liter. Yeah. Okay. Well, the judges heard it as, because it's a different way of answering the question. It's probably correct, she said, if you change it. So I think we will accept. No, the answer is still wrong. Yeah, there's not enough zeros. Yeah. If it was 0.004 micromole, then you'd be correct. Yeah. Yes, it's 10 to the power minus 9. Okay, right. Okay, right. So both are wrong. So sorry, we've taken longer time than I expected. I was expecting a quick answer to this question, but sometimes you never know. Yeah. Okay, let's move on. Number 4. Name the 2 lung capacities that cannot be measured by spirometry. Name the 2 lung capacities that cannot be measured by spirometry.
They are total lung capacity and functional residual volume capacity.
That's correct. Okay, your question is number 5. What gradient accounts for the fact that the amplitude of an action potential generated along the axon is always the same size? What gradient accounts for the fact that the amplitude of an action potential generated along the axon is the same size?
Because after the sodium voltage gather channel was activated, it will be inactivated immediately after that, and that's why it's caused to reach the peak of the action potential and cause the amplitude to be the same as.
So, what is this gradient? We just want what gradient accounts for the fact that amplitude is the same. Just name the gradient.
The gradients of concentration of is the gradients of sodium ion.
That's correct. Yep. Okay, second cycle. Okay, just press the bell. Okay, good, right. Okay, your question is, if the diastolic pressure is 60, and the systolic pressure is 90, I'm giving you 3 answers. Would the mean arterial pressure be 70, 75, or 80? State your reasons. If the diastolic pressure is 60 and the systolic is 90, would the mean arterial pressure be 70, 75, or 80? State your reasons.
70.
Why?
Mean arterial pressure is the 1/3 of the pulse pressure added to the diastolic pressure.
Why do you need to use this formula instead of averaging it?
Sorry, sir.
Why do you need a formula instead of just taking the average?
Because the mean arterial pressure is always near to the diastolic pressure.
The mean arterial pressure is near to diastolic pressure. That's not the reason. So, answer is wrong. Yes.
The answer is 70 because diastolic is 2/3 of the cardiac cycle and the systolic is 1/3 of the cardiac cycle.
Okay, correct. Yeah. Yeah, the diastolic phase is longer, so you cannot simply average it. Yeah. So, okay, your question: state the change in the efflux of an ion, efflux E, yeah, EFF-LUX, that lead to a change in the postsynaptic potential. State the change in the efflux of an ion that can lead to a change in the postsynaptic potential.
So the postsynaptic potential is determined mainly by the efflux of potassium ions.
Describe the change. Increase, decrease, and what happens? Yeah.
Okay, so the potassium ions will move out to the cell, so it will decrease inside.
No, you have to state the change to the ion, the change to the efflux, increase, decrease, and give us the change in the potential. Yeah.
Can you repeat?
State the change in the efflux of an ion that leads to a change in the postsynaptic potential. Just give an example. Yeah.
Maybe during the polarization, the
Okay, choose your ion. If I help you, choose your ion. What are you going to talk about?
okay, calcium.
Calcium.
Okay, potassium. Sorry, potassium.
Yeah.
Okay,
Potassium. Okay.
Potassium.
So what happens to the efflux?
to the efflux.
Yes.
Potassium will increase the efflux.
Increase efflux of potassium. What happens?
So the inside will be, what do you call it? Go down. Yes. So the
How does the membrane potential change?
the membrane potential will fall when potassium is getting out.
Fall means becomes more
More lower to the resting membrane potential.
lower.
Yeah. How do you state it? Yeah.
Yeah, how do you say it? That's right. Yeah. Lower, is it more positive or negative?
Negative.
Okay, you're correct. Yeah. Yeah. Okay. Yeah. Okay. Question. Third question. Why does the renal sympathetic activity tend to decrease the renal blood flow more than the glomerular filtration rate? Okay, simple answer. Why does the renal sympathetic nerve activity tend to decrease the renal blood flow more than the GFR?
Because it constricts both afferent and efferent arterioles, the sympathetic stimulation. So the GFR will decrease, but the blood flow will wait.
Okay, quick. Yeah. The clock has been stopped for you. Yeah. Okay, no answer? Yeah, we'll open. Yep.
Well, yeah, I think sympathetic it will constrict the afferent, so afferent arteriole, so it will reduce the renal blood flow. About the GFR, it will depends on the autoregulation. So
Yeah, answer is wrong still. Yeah. It's the blood flow will decrease whether you constrict afferent or efferent. but the GFR doesn't drop as much because one side tends to decrease it, one side tends to increase it. You follow that? Yeah. Okay. So the filtration fraction, in terms of filtration fraction, changes as a result. Okay. Yeah. Okay. Fourth question to Vietnam: how is transpulmonary pressure calculated? How is transpulmonary pressure calculated?
Transpulmonary pressure, is it a difference between alveolar pressure minus, it is a difference between alveolar pressure and intrapleural pressure?
Yeah, that's correct, yeah. Okay, Mahidol, your question is, in the descending vasa recta, state the direction of movement of sodium and of urea. In the descending vasa recta, state the direction of movement of sodium and of urea.
In the descending vasa recta, the movement of urea and sodium will move
into the vasa recta?
Yeah.
Answer is wrong. Yes?
In the descending of the vasa recta, sodium and urea move from the interstitial to the capillaries.
Say that again, slowly.
Yeah, in the descending limb of the vasa recta, the sodium and urea will move from the interstitial to the capillaries to the vasa recta.
Sorry, let me get your answer again. I might be reading it wrongly. Did you say in? Both? What you answer? Can I go back to my thought? Yes. What was the answer?
Yes.
Both sodium and urea move in.
Yeah.
Sorry, your answer is correct. I beg your pardon, yeah. Yeah. I'm so sorry, yeah, because yeah. Okay, let's check your bells here. So the brain cannot take too much in and out language after a while. Okay, I'm so sorry to Mahidol. Yeah, your answer was correct. Yeah. Okay, last cycle of third question. Name the two short answers. Name the type of glia cells involved in the myelination in the peripheral nervous system and in the central nervous system.
Peripheral, it's oligodendrocytes. Central, Schwann cells.
Say that again clearly, loudly, so that Joshua can hear.
Central nervous system, it's Schwann cells.
Okay.
Peripheral, it's oligodendrocytes.
Peripheral is oligodendrocytes. Do you say that?
Yes.
Answer is wrong. Yes.
I'm sorry.
No problem.
I hope it's not broken. It's the otherwise. The central is oligodendrocyte and the peripheral is Schwann cell.
That's correct, yeah. I think you're probably nervous, yeah. Relax, yeah. Okay, your question, sorry. In hypervolemia, HYPR, state the neural reflex that produce a change in the renin secretion. In hypervolemia, state the neural reflex that produce a change in the renin secretion.
In hypervolemia, there are many factors affecting the change, the regulation to lower the blood pressure. First,
no, we just want a short answer. Listen carefully.
Okay. There's
wait,
inhibition in RAAS system.
Listen carefully. We want a short answer. In hypervolemia, state the neural reflex, not all the other things. State the neural reflex that produce a change in the renin secretion. That's all we want. Don't explain blood pressure control, okay? We don't have time, yeah.
So there is a decrease in sympathetic control, which decrease the RAAS system.
Decrease in sympathetic, that decreases
Hypervolemia.
RAS system.
Neural mechanism.
That's correct, yeah. Yeah, that's all we want, okay? Thank you. Okay, your question is name two adrenal hormones that have hypokalemic actions. Name two adrenal hormones that have hypokalemic actions.
Aldosterone and cortisol, a slight effect.
Answer is wrong.
The aldosterone and the catecholamine.
The
catecholamine.
Catecholamine, that's correct, yeah. Okay, the effect of cortisol is very minor in a normal person. So it's adrenaline. Yeah, two major hormones that have hypokalemic. Aldosterone, definitely, and adrenaline. Yeah. Okay, the fourth question, name the secondary active membrane exchanger that is involved in cardiac muscle relaxation. Name the secondary active membrane exchanger that is involved in cardiac muscle relaxation.
I think that is sodium calcium exchanger.
That's correct. Okay, Mahidol, your question is, last question in this session. Atrophy of which specific gastric cell will lead to a deficiency of an essential erythropoietic factor? State the function of this factor. I repeat, atrophy of which specific gastric cell will lead to a deficiency of an essential erythropoietic factor? Second part, state the function of this factor.
The atrophy of the parietal cell, which can produce the intrinsic factor that help in the B12 absorption.
That's correct, yeah. Okay, just looking at the scores. Okay, the winning team of this session is Mahidol, and we will wait for the best 4 teams with the highest score to join them. Yeah. Okay, let's move on to number 6.